a phenomenon that we call the pressure paradox. And this has to do with the way that we perceive what we call weight, okay, or what you might think of as mass. Okay, so the way that we perceive weight, it depends on density. So looking at these objects, these are little foam balls, very, very light to the touch. And if I were to pick up this shot put, which is about the same size, each of them is about 10 centimeters in diameter, about the same volume, right? Oh, well, obviously the metal one made of iron is way, way more massive, and I know that for sure, there's no doubt, because we're comparing things that are of equal volume. But what about a little itty-bitty little ball like this? Well, this has a very different volume. This is only about 1 centimeter diameter. So let's put those in my hands. Now, it's hard for you have to take my word for it. It'd be better if you were doing this yourself. But this metal ball is pushing down on my hand quite a lot more than this feels like it is. So I'm pretty sure, pretty convinced that this is heavier, that this would have a greater mass, okay? So I've got my little electronic balance. I put the bowl on, tare it, so now it's zeroing out the bowl. Let me just do that again, zero out the bowl, so it's all zeros. Put this one in. Turns out that little ball is about 8 grams, 8.38 grams, 8.38 grams, okay? Wonder what this is. So this must be less than that, right? Put it on there. Oh boy, 14.00 grams, 14 grams. So this is about 8. This is about 14 grams? So why would this feel heavier in my hand? Well, so remember that pressure, which is what we feel on our hand, we feel the pressure on our hand, is the force divided by the area. And obviously the area for this is much smaller. So if you take the mass of this object, which is about 8 grams, divided by the area for this object, well, the part that is touching my hand, which would be hard to calculate. I mean, you could calculate the surface area of a sphere, but then it's not the whole sphere that's touching my hand. It's not even really half of it, just a little part of it on the bottom, about like this much, I guess, that is actually pushing on my hand. So that the whole weight of that object concentrated on that little area. Whereas this one, which obviously has a greater overall mass, is over a much bigger area. So it's force divided by area. So the pressure that we feel, because it's force divided by area, well, it depends on a number of things, including the density of the object. So a lot of times a denser object, like a piece of metal, will feel heavier, like more mass, than a low dense object, what we call a rare object in your hand. Interesting, it's kind of a paradox. That's why they call it the pressure paradox. Now let's see if it works for more of these. Let's get, I don't know if I can fit 3 of those in my hand. I could probably fit 3. So let me see. 3 of these, yeah, I can feel that. Pretty heavy. And what about 3 of these guys? Okay, well, it's kind of hard to get them all in my hand. Oh yeah, this feels like nothing. And this, I can really notice it. So it's it's a very obvious sensation. And if you did this yourself, you would agree with me that these feel heavier, but put them in there. What's their mass? 25.13. 25.13 grams, whereas this is going to be more than that. 43.48. So not quite double, but almost double the mass. And yet it doesn't feel that way. So that's the pressure paradox. Okay? Bye.